Hey, how you doing? Welcome to today's lesson. What we're looking at today is congruent triangles. Okay, congruent triangles. Okay, now the thing about congruent triangles is any shape, let's put it this way, any shape that's congruent, okay, to another shape means it's exactly the same, alright? Same size sides, same size angles. So you can get congruent rectangles, congruent triangles, congruent pentagons, congruent anything basically. Okay, but specifically today we're going to be looking at congruent triangles, because with congruent triangles we use them a lot in proofs. Okay, they're very powerful to show that two triangles are congruent, which means they're exactly the same, and then you can say other stuff about other angles that aren't, or other sides that aren't shown. Alright, now the thing about congruency is there are 4 cases for congruency, and the 4 cases I've got listed there on the notes. But the first one is side, side, side. So if I can show that all 3 sides of a triangle are equal to all 3 sides of another triangle, then those 2 triangles have to be the same. Okay, they have to be congruent. The other one is side angle side, side angle side. So if I can show that 2 sides of one triangle and the included angle, the angle between the 2 sides, it's quite important, it can't be an excluded angle. It has to be the angle between the 2 sides, side angle side. If I can show that those are equal, then the 2 triangles are congruent. Okay? Or you can have angle side angle, angle side angle. Okay? You could also have side angle angle, alright? A little bit trickier. But angle side angle means if I've got the same side and 2 angles, I can prove that those 2 are equal, alright, or congruent, equal. And the last one is right angle hypotenuse side. Right angle hypotenuse side. If I've got one of the angles is a right angle, okay, and I've got the hypotenuse and the side of the other one, alright, those 2 have to be congruent. The reason for that is that if I've got 2 sides of a right angle triangle, I can always use Pythag to work out the 3rd sides, and then I'd be back to side, side, side. But we don't bother doing all that work. We just say we've got right angle hypotenuse side. Alright, you with me? Super. Let's do one. So, the question that I've got there, okay, I've got 2 triangles there. I've got ABC, there it is, okay, ABC, and it's 30, 50, and 8. 30, 50, and 8 centimeters, alright? And then I've got DEF, like that, DEF, and we've got 50, 30, and 8. 50, 30, and 8 centimeters. Now, I hope you can see that these 2 are actually the exact same triangle, alright? So they're the exact same. I've taken ABC and I've flipped it like this, and I've got it over there for DEF. Okay, it's the same triangle. But the problem is not, oh, well, if they say show these triangles are congruent, you can't just write down they look the same, right? 0, nothing, no, they're, oh, well done. Yeah, but they're not. That's not the proof. The thing is, you have to work on your layout. So the layout is important with this. All right. So we say in triangle ABC, right, and in triangle DEF. All right. So that's what I'm looking at. I'm looking at the congruency proofs for these 2. Now, different teachers will have slightly different layouts. Some teachers say required to prove congruency in triangle yada yada and in triangle yada yada, okay? Some teachers will just say put it down. Some teachers will just let you list the things and go straight to congruency. It's all dependent on the personal preference of your teacher, okay? This is the way I like it. Right. So first you have to list what's going on. Well, I've got AB is equal to DF. AB is equal to DF. That's 8 centimeters, that's 8 centimeters, and it's given. Alright? Now all of these in this one will be given, the reason will be given. Sometimes you'll have to use one of the parallel line rules, especially if you're dealing with 2 triangles in a picture. Okay? And you can use alternate angles that equal corresponding co-interior add up to 180. So anything like that. Alright? But this is all given. This is quite a straight one. So the reason will be given each time. I'm not going to bother writing each time. Okay? Now, angle A is equal to angle F. Angle A is equal to angle F. Okay? Or you could do angle BAC is equal to angle DFE. Alright? Depending on how strict you are required to be with your proof. Lastly, angle B is equal to angle D. Okay? Alright? Also given. So now I can say that these 2 triangles, triangle ABC is congruent. It's a 3-line equal sign. Okay? It's the same thing that we use for identities. Alright? To triangle, now this is quite important. The sides have to correspond. So A is F. So F. Then B is D, and then lastly C and E must be the same. So like that. Okay, they have to match up. Vertices have to correspond. Okay, and what's my reason for this? Angle, side, angle. Angle, side, angle. So my reason is ASA. Okay, or you might be required to write that out in full sentence, saying and two angles and the included side. Okay, but sometimes I've seen most of the time we just accept the abbreviation like that. Okay, check with your teacher. All right. So that's pretty straightforward. Proving two triangles are congruent. You have to learn those 4 rules, please. You have to learn those 4 rules, and you have to just go practice them. A very cool way to learn those 4 rules is to learn how to construct triangles. Okay, this is not what this video is about, but go and look it up on the internet, how to construct triangles using a protractor, using a compass, and a ruler. All right. Then you'll see how to construct similar triangles using those 4 things. Okay, so let's look at how to use them in proofs. All right, so I'm going to quickly hash together this picture, but it's not going to be accurate. It's pretty nice it's pretty nice the picture that I've got actually on my on the notes. So the picture that I've got there is I've got a circle, all right, and I've got PT as a tangent, and I've got QT also is a tangent. Oh, let's just make these two guys join. Okay, all right, and I've got the center at O, right? So let's draw this nicely there. Oh, this is not going to look accurate because I've drawn this as an oval, not really a circle, but it's fine. And they say required to prove that PT is equal to QT. Now this is actually how you prove, I just want to draw this in here quickly. I can't multitask and I can't draw a straight line either. So this is actually how you prove that two tangents are equal. So this is PT and QT. Alright, and they say prove that these two are equal. They're required to prove that PT equals QT. Okay? So if I'm required to prove PT equals QT. Alright, so what can we say about these things? Firstly, let's look at these two triangles. So I'm going to look in triangle, POT, and triangle QOT. I find it's a good idea to correspond the angles from the get-go, alright, to have them corresponding, because you can kind of see Q and P will be the same size, O is the same, T is the same, so I line them up in the beginning. So let's take a look at this. Firstly, we can say this. I'm going to color code this. OP equals OQ. So OP equals OQ, right? That equals that. Why did they equal? Because they are radii of a circle. They are radii. Okay, so they have to be the same size. Right. Angle OPT, right, angle OPT, the P is the angle, is equal to angle OQT, that one, alright, and the reason, and they're actually equal to 90 degrees, so radius tangent equals 90 degrees, so radius meets a tangent at 90 degrees, it's one of the circle theorems, okay. So this is something you can probably get after you've got done the circle theorems, okay? So the radius meets a tangent at 90 degrees, so those two equal, all right? And lastly, what can you say? OT is common, all right? So here, OT equals OT, or you could say it's common, okay? So common side, right? I don't think there's two M's in common, okay? So OT equals OT common side. Well, hang on a second, what have I got? I've got a right angle, the hypotenuse, and one on the side. So therefore, I know this seems long-winded, but this is a watertight proof, okay? So therefore, right, triangle POT is congruent, 3 lines, to triangle QOT, and the reason is right angle, hypotenuse, side. That's what I've got, right angle, hypotenuse, side, okay? Now, because they are congruent, because they are exactly the same, that means that the third side must be exactly the same. That's what you're proving here. Okay, I haven't jumped immediately to the third side. We've shown that the triangles are congruent. So therefore, PT must equal QT. Triangles are congruent. Okay, so PT must equal QT. You with me? Alright, so this is quite powerful, and this is the main reason why we use congruency, because we take a proof, we say, okay, well, great, how do I show this? I've got two triangles. My personal preference is, I see two triangles, I jump to prove congruency. I say, okay, two triangles, let's see, if I prove them congruent, will that help me answer the question? Okay, in this case, it does. Right, I proved that one's congruent to that one, exactly the same, therefore the last sides must be exactly the same. Okay, you can try and do this using Pythagoras. That squared minus that squared gives you that squared, set them up, make them equal, work it out algebraically, but that's a little bit long-winded. It's actually, believe it or not, I think, easier to prove PT equals QT using congruency. Alrighty, now this takes practice. It takes practice to see when to use it, to see what to use, to see what to go for. You need to go and find examples, you need to go and do them, you need to go look at the model answers for them, because you've just got to get practice at this. Okay, alright. Come watch this again, it was a little bit tricky, and remember, I'm here for you.